and then see if you can simplify. I don't know that you have to do that, but that's what I'm sure. So change everything to sines and cosines, and as we get into section 5.2, as we do these identity proofs, I have this whole list of strategies for you, and my very last strategy is, if all else fails, change the sines and cosines and see if you can see if anything happens. Because you can write every trig function in terms of cosine. So if we do that on 27, we can use those quotient identities to change tangent to sine of x half theta and sine of x. Those are all x's. This is the hard part of this. I don't always get into so that's sine of x over cosine of x, and then cotangent would be cosine x over sine of x. What do you want to do next? If there was addition, right? So multiplication, they would just all cancel out. Addition, it doesn't cancel out. So I see two options. One option is we could distribute the sign in to get rid of our parentheses. The other option we could do first is, if we have two fractions added together, could I get a common denominator and add them together? Whoa. You do that. You might have to do that at some point. But let's distribute first. I'm going to do that. I'm going to distribute. So if I take sine times this, sine times sine is sine squared. And then I have cosine on the bottom. And then if I distribute this over here, you agree that the signs will cancel out? Yes. I'll have a sign on top and the bottom. And that will just give me plus cosine. So today, this is what we're going to talk about. It's one of our big ideas today of getting a common denominator, which I feel like we have to do. Over 1 right now, just has cosine. I want to add or subtract fractions. They have to have a common denominator. Just like if they both had a denominator of 3, I could add them together. This one has a denominator 1, which has a denominator of cosine, which means I need to make them both have a denominator of cosine, right? That'll be my common denominator. Which means I don't have to do anything over here, right? So I'm going to go ahead and leave that as sine squared. But over here, I would have to multiply by a cosine in order to make that denominator. Which means, remember, the only reason I'm allowed to do that is if I also multiply the top by cosine, and cosine over cosine is really just 1. So then look, cosine times cosine is cosine squared. And I know where to go next. What is sine squared plus cosine squared? Great answer, but it's the wrong answer, which is why I wanted you to check your answers in the back of the book, because we can always simplify a trig function in the bottom of a fraction. We can always bring it up as its reciprocal. So instead of writing 1 over cosine, the better answer there, the more simplified answer, and the answer in the back of the book, is that all of that just simplifies down to secant. And we're going to do a couple examples. Really important things to make sure we're aware of right now are our rules of algebra. What we're allowed to simplify, what we're allowed to cross out, not making up our own math lists. That's the one. So 39, the directions say, write each expression in factored form as an algebraic expression of a single trig function, which means they only want you using one trig function, sine all the way through or cosine. So this one, again, you have to kind of get practice at doing this. So when I see a squared function, a not squared function, and a constant, right, that's a trinomial, which means I can either do U substitution, like in our notes yesterday, or you could just factor it, where you make your two parentheses. And again, these directions on this first section, they kind of tell you what to do, like factor this into a binomial. So if I don't use U substitution, I would just say what multiplies together to give me cosine squared. I would just say cosine. What multiplies to give me 1, so that gives me 2. And you could leave it like that, or you could write it as the quantity squared, right? But that doesn't equal anything else. Like that's it. Like either one of those two lines there. Because you can't simplify that. Or neither. So that's just factoring it. And the idea is eventually, and maybe you can even see up on 51 to 56, those are equations. And tomorrow, we're going to solve equations using these algebra techniques, which means you can see that factoring is one technique that you can be able to solve the values. These are the ones where they got a little more complicated. Right? 42 kind of looks like 39, only a lot harder, because in 39, they were all the same trig function. You can just factor it. You can't factor something when there's a sine and then there's a cosine. So step 1 on this is we need to make them all the same function. We need to either make that all sines, or we need to make that all cosines. Is there any way that you can just turn plain old sine into cosine? Look at this. Cosine squared, is there a way I could write cosine squared in terms of sine? Yes, because of the Pythagorean identity. So remember that I have sine squared plus cosine squared equals 1. And it's kind of up to you on how you want to do this. I just plugged in for cosine. Like I solved for cosine squared and said, well, that means that cosine squared equals 1 minus sine squared. You got to really, really watch your negative signs in this, because there's a negative in front of the cosine. So when I plug that in, I have minus the quantity 1 minus sine squared minus 1. So I replaced cosine squared with Pythagorean identity, but because there's a subtraction sign in front, that subtraction is going to go to both of those. So you have to, again, really watch your distributive formula. So when I do this, that's going to give me minus 1 plus sine squared, and then minus. Now we've turned 42 into something that kind of looks like 39. Now I have a quadratic where my squared term is first. And then I'm going to say plus sine x, and then negative 1 and negative 1 is minus 2. Right? That was kind of tough. Now you can factor it. I'm going to stop there, and you can factor that just like we factored number 39. Where 1 multiplies would be 2 squared, 1 multiplies would be 2, that subtracts would be 1, and then that's it. You can't go any further than that. 45, kind of like 42, in that we cannot factor, right? The direction says factor. We can't factor when there's a whole bunch of trig functions in there, which means we have to simplify this. So right away when I see tangent squared and then I see cotangent in the bottom, I think, wow, if I just move cotangent up, that's going to make tangent. So that's a good thought, because then I want them all to be tangent. Okay, so that's just going to be minus 4 tangent x, right? That's the reciprocal identity. Just look it up. And then what happens over here when I have sine times cosecant? What's that going to equal? It's just 1. Sine and cosecant are reciprocal functions, right? Or you can think about sine and cosecant is 1 over sine. Remember we talked about yesterday that those will always cancel each other out. So 39 kind of set up for you. 42, you have to do a little bit of substitution. 45, you have to do 2 substitutions, or 2 simplifications to get the plus x. And then also 45, you have to factor with the number in front, right? And so usually when we factor stuff like that, we did the factor by grouping, right? And we see a number in front like this, the way that we factor is we take 4 times 1, and we get 4. And then we ask ourselves, well, multiply to give me 4, that adds to give me negative 4. Well, that would be negative 2 and negative 2. Right? And so I'm not using U substitution. So I just say negative 2 tangent x and negative 2 tangent x. Or you could do your U's there if you want. Okay, you remember doing this? Factor by grouping? Then you bring down the first and the last terms. Right, so that factoring technique that you did in Algebra 1, that you did in Algebra 2, that we did first semester precalculus, you have to know how to do that to do trig factoring as well. And so then that's where you can group these two together. You can take out that 2 tangent x, and you're left with 2 tangent x minus 1. Remember, you want these two parentheses to be the same, so that means we need to take a negative 1 out of that. That would give me 2 tangent x minus 1. You take out the parts that are the same. Right? You take out those parentheses. You put together what's left. And that's really the same thing twice, which means you could just write it as the quantity squared. 2 tangent x minus 1 quantity squared. And if we solve these equations, you're going to have to factor, which means it never hurts to kind of review some of your factoring stuff. And then all we're doing here is we're using trig functions. Because didn't we say yesterday that 1 over cotangent x is equal to tangent x? Right, isn't like that's a reciprocal? So just because there's a 4 on top, right, like that just means that there's a 4 with it. But anytime you have a trig function in the bottom of a fraction by itself, you can always just bring it up and make it its reciprocal. Okay? If you have a lot of these you still haven't done, you need to keep working on them. If you are stuck on some, I'll be happy to help you. But if you just have blank spots in your homework because you haven't even tried them, you just looked at them and moved on, you need to try those before you come and see me, because it doesn't help you if I just do them all for you. The notes are pretty short today, so you're going to write them yourself. I know, it's terrible. That's just spoiled you. So again, today we're just still looking at simplifying. The only difference is we're going to look at maybe some uglier ones that might be terrifying to you because yesterday's homework might be. But today we're going to look at more fractions, and I think, for me, I call fractions the worst ones because people really struggle getting common denominator sometimes, or breaking the walls of math when it comes to fractions because they just come across everything else. So kind of reviewing those topics are helpful. And then tomorrow is the last day of 5-1. And tomorrow we'll use these techniques to solve equations as we go into year next week. Okay? So day 2. And again, your homework today, they try to give you some advice, like get a common denominator, or add and subtract, or try to simplify down to one trig expression. But again, eventually, very soon next week, they're not going to give you any advice on how to solve these. And so you want to start recognizing, hey, that looks like a trinomial, I can factor that. Or if I see two fractions together, I have to get a common denominator before I can do anything. And so again, kind of creating that list of what are my options of what would make this a simpler problem. We cannot cancel anything out here because it's subtraction. We could not break up addition and subtraction at the bottom of the fraction. So all kind of things to remember. Which means if I was looking for a common denominator, right? Those have nothing in common because secant x plus 1 is completely separate than secant x minus 1. So remember, sometimes I think the easiest common denominator is if you just take each denominator and that becomes your common denominator. Right? So my common denominator here is going to be secant x plus 1 times secant x minus 1. And then remember, when you add fractions or subtract fractions, it's all about multiplying the top by what you had to do to the bottom. And so I don't usually show what I multiplied to the bottom because I already rewrote it. But like I always look at this and I say, what do I need to make this match this? Right? I have the secant x plus 1, so I need the secant x minus 1. So that means on top up here, I have to multiply by secant x minus 1. And on this side, I have the secant x minus 1, but I need the secant x plus 1, right? So that would make secant x plus 1. But be really careful, right? It's subtraction. So remember that you're subtracting all of that. It always stinks when that's the mistake you make, is you have a plus sign when you have a minus sign there. So times 1, so that's easy, right? So this becomes secant x minus 1 minus, that's going to become minus secant x. If you're also subtracting the 1, right? You're subtracting that whole quantity. So it's not plus 1, it's minus 1. Questions on where I got it? Once you get a common denominator, the hope is doing the simplification. You're going to see some stuff that you cancel out, or it's going to turn into something that you can simplify. So on the top here, really great, secant x minus secant x cancels out. So that's just -2, right? Notice if you forgot to distribute your negative, you get 0 on top. On the bottom, we talked about this yesterday. If I have two things, difference of squares here, and I multiply them out, that middle term is going to cancel out every time. Secant x plus 1 times secant x minus 1. So I'm going to go ahead and multiply that out. And that's going to give me secant squared. My middle term's going to cross out, so I'm not even going to write it. And then 1 times -1 is -1. We really like difference of squares with our trig stuff. There's not always, almost always, what's going to end up being something like right? So that middle term drops out, you get a square term of 1. So now we have to go back and say, which Pythagorean identity has secant squared? Have those memorized yet? 1 plus tangent squared equals secant squared. So look at that. Look at this. See if you can do some substitution there to make that work, right? If I just subtract that 1 over, does that mean that I can replace that bottom with just tangent squared? Yeah. Now I have -2 over secant. It's always better if you write it as one fixed function as opposed to subtraction. It's a good answer, right? Look at the back of the book. If this was not a question, it's going to be simplified more, because if tangent is in the bottom, could I bring it up and make it not a fraction anymore? What's the reciprocal of tangent? Cotangent. So you just bring it up. Notice it is squared. We're just going to square the cotangent. So -2 cotangent squared would be the answer that the book gives. And that's something that takes some practice to recognize it. Oh yeah, I don't want to put it up. And that's why you should check that. So that if you left it like that, you could look in the back of the book and be like, oh yeah, I just did that. Doing the common denominator correctly, really, really important as we go. Questions about that? I'm going to give you a head start on this one, and I'm going to see where I'm going. Just like the last one, these have nothing in common, right? So my common denominator is just going to be 1 minus sine x times cosine x. So think about what you need. 1 minus sine x times cosine x. Think about what you need on the top to get that. I'm going to kind of give you a minute to get a head start. Denominator, you want to kind of look at the top and say, is there anything that maybe could be on? Don't forget on that top there, right? That minus sign, that we have to distribute that, right? So that should become minus sine x plus sine x squared. So I don't multiply my denominator out right first on the last one. I think that multiplying it out because it was a difference of two squares. When I look at this denominator, if I multiply cosine through there, is that going to work out to anything at all? No. So my new goal is my denominator did not simplify. So I want to look at the numerator. And Mackenzie, what did you notice? Right? Adding and subtracting, you can break it up. You can put it in different order. We have a cosine squared plus a sine squared, which means we can put those together, and that just equals 1. So if you plug in sine squared equals 1 minus cosine squared, that'll work too, like if you did a substitution. But you definitely want to see that you can put those together to simplify that. So if we say that cosine squared plus sine squared equals 1, then now do I have 1 minus sine squared left on top? You agree with that? So do you see something else we could do now that we did that? I can't break up addition, subtraction, and a fraction, but I can cross out entire factors, right? So now I have a 1 minus sine x on the top and a 1 minus sine x on the bottom. So I can cross those out. Remember, we're dividing here, so the top and left is 1 over cosine x. Am I going to leave my answer 1 over cosine x? No, I'm going to flip it up, and I'm going to make that. Our part is because I can't tell you every time what to do. Okay? There's no like step 1, step 2, step 3, you always get an answer. But you have to look at it and use your ideas, and that's what's really fun about it. I think what I love about it is that people can do it different ways and still get the right answer. And so I still love it. See different things that I get. This one's a little different, right? There's no common denominator here to get. I can't cancel something out right now because nothing cancels out. I can't break up addition, subtraction. So again, for me, I always look to think about, could I write these in the same trig function, right? If I had sine, or if I had cosine, maybe I could get some different out. 1 plus just cosine, right? That's not cosine squared. It doesn't equal anything. So I say we can do nothing with that. What about the top? Can I rewrite sine squared so that it's at cosine? So if I could plug in what that equals in terms of cosine, then maybe I could simplify it. And so to me, that's a really good strategy. Try to get them in the same trig function if you can. So remember that we could just subtract this over. Would that be the same as saying 1 minus cosine squared? Excuse me. Here's what's not okay to do, right? Do not just start crossing things out here, right? We can't break up addition and subtraction. So do not cross out your 1s and cross out a cosine and tell me the answer is cosine. We're not allowed to do that, right? We can only cross out factors. And you're on the right track if you think, hey, something's going to cancel out here. Just that top step. If you factor a perfect square minus a perfect square. Oh, yes. A squared minus b squared will always factor into a minus b, a plus b. So when you see a perfect square minus a perfect square, even if it's a trig function, right, I can factor that into 1 minus cosine x and 1 plus cosine x. I think about, we multiplied yesterday, today we're breaking it apart. And now we could cross something out because we have an entire factor. So we can't break up addition and subtraction, but we can factor factor, and now this whole thing will cancel out, and I'm left with 1 minus x. I'll tell you a common mistake that I see on this is people want to tell me this equals sine of x. That's not true because why? It's not squared, right? Pythagorean identities have to be squared, which means this doesn't simplify. That would just fit. You never know what's. Oh my gosh, there's nothing next. That was a lie. If you notice today, there's not as many problems, which means if you still have a lot of unfinished problems from yesterday, please go back tonight and look at those as well. 33, 34, 36, those are all 38. Those are all common denominator problems. And then 47 and 48 are more like the last one. It is a try time day, so we have less time than normal. But if you have other questions, and yesterday you want to ask me, if you have questions you want to ask me, or if you just want to work on this homework, again, keep trying these, and you're going to get better at them. And tomorrow we're going to throw in solve this week.